Yes, class. So in the last class, we had started with vectors, just the basics of vectors we had covered. So look here, class. When we are talking about vectors, one thing we all should be aware of, that this fact, whenever this quantity, this is written to you like this, you should be able to identify, look, v is equal to -4 meter per second if you have. So velocity is the physical quantity. Now, physical quantity can be anything. It can be your force. It can anything, any quantity, your velocity, your acceleration. These can be physical quantities, which we have studied in dimension analysis. Is equal to is just a mathematical operation. Minus negative sign tells you the direction. Because we are talking about vectors, vector quantities have specific directions. We cannot neglect their direction. So that's why we put a negative sign. 4 is the magnitude of it. Okay, Sarah, take 5 minutes. 4 is the magnitude. Whenever I'm asking you the magnitude, you have to tell me the number without the signs. Even if it is written -4 meter per second, when I'm asking you the magnitude, that doesn't make your answer -4. You will still answer 4 only. That is the magnitude, the number without any signs, plus or minus. And meter per second is the unit. This you all should remember before starting with the class. And one more difference we did between vector quantities and scalar quantities, because if you do not know the difference between vectors and scalars, so how will you be able to identify whether you are talking about vector quantities or scalar quantities? So vector quantities have magnitude, direction, and they obey the vector laws. Vector laws we have not started. Most probably by the end of today's class we'll be able to start it. Vector laws like parallelogram law, polygon law, these laws get used in vector. So class 3 conditions have to be followed when we are talking about vector quantities. First one is the magnitude. Means magnitude will be there in scalar also. Magnitude will be there in vector. With just seeing the magnitude, you cannot predict whether a quantity is scalar or vector. Next thing, direction. There is no direction when we are talking about scalar quantities. But when we are talking about vector quantities, we have direction. Simple addition, subtraction, multiplication, division, these are valid in your scalar quantities. If I give you distance, distance is a scalar quantity. If I give you speed, speed is a scalar quantity. So you can add two speeds directly. You can subtract, you can divide, you can multiply. All these 4 basic algebraic laws, your trigonometry, all your basic algebraic laws will be valid. But when I'm giving you 2 velocities, till now we had discussed motion in a straight line. So in motion in one dimension, there wasn't actual application. That also you will see after we do parallelogram law, that why didn't we consider motion in 1D also with the vector laws? Actually, you were considering, but that is a special case, one dimension. That's why we were able to manage with simple addition and subtraction. Nextly, velocity, force, acceleration, these are all vector quantities. We have done this part. Now, we had started with unit vectors. Unit vectors are very important for all of you to remember. Along positive x-axis, you have plus I cap, negative x-axis minus I cap. Whichever direction you want to depict. Suppose I want to say the forces along positive x-axis. So I'll just put an I cap with my answer, like 2 Newton force along x-axis. So my answer will be 2 I cap, right? For y-axis, we have j cap. So positive y-axis plus j cap, for negative y-axis minus j cap. Now the axis that is outwards is your z-axis. For z-axis, the unit vector involved is k cap. Outwards again, backwards, both the same thing. You have for positive z-axis, you have plus k cap. For negative z-axis, minus k cap. This we did. These are the unit vectors. And what is the definition of unit vectors? What is meant by unit vectors? Unit means 1. So the vectors whose magnitude is 1, even though it is written -1 or it is written +1, the magnitude will be 1 only. So with whichever, it is a unit vector. Now, how to solve the questions? Till here only we could complete on the last class on Tuesday, right? So A1 I cap plus A2 J cap plus A3 K cap. In this way, your vectors will be given in Cartesian form. Right now, we are doing Cartesian form. After this, we'll discuss the polar form. Polar form is your laws and all, parallelogram law and all. When we talk about Cartesian form, they are written in I cap, J cap, A cap. Means in the form of axis, in terms of axis. So whatever coefficients are there, 2 is the coefficient of I cap, 3 is the coefficient of J cap, 4 is the coefficient of K cap, right? So A1, A2, A3, any coefficient you can have along with the main unit vector. Now, how to solve it? How to solve the questions? How to actually perform calculations? Suppose this is an example. I cap minus 2 J cap plus 3 K cap, right? Now, see, in this case, what we have to do? The formula I had told you know in the last class, yes. To make a unit vector, what you have to do, take the vector as it is and the magnitude of vector. Now, coming to how to take the magnitude of vector, this is very basic for all of you. And these will be utilized till the end, till class 12's last lesson. Everywhere you will be needing these. So please pay attention to your basics. These are your building concepts, and motion in a plane also you will be needing it, and rest of the lessons you will be needing this too. How to make a unit vector? I had told you the formula in the last class. It is take the vector as it is, divide it by magnitude. Now the question comes, how to take its magnitude? If I had just a number 3 Newton or 3 meter per second, 3 kg, something, some physical quantity with the magnitude 3. So magnitude would have been 3. Now I am having, this is my question, I cap minus 2 J cap plus 3 K cap. So how would I get my final answer? What is the magnitude that I should take? Should I consider 2 as the magnitude? Should I consider 3 as the magnitude? Should I consider 0? How should I take the magnitude? So see, whenever you have these Cartesian system, there is one specific formula by which you will go, and that's how you calculate its magnitude. Formula basically says that, here I'll tell you the general one first. If you are having this A1 I cap plus A2 J cap plus A3 K cap, then magnitude of this vector A, this is given by under root square of the coefficient of I cap, that is A1 square, plus square of coefficient of J cap, plus square of the coefficient of K cap. Whatever will be my answer, that would be the magnitude of it. Clear? For example, this question, when we are talking about this question, I cap minus 2 J cap plus 3 K cap. Look here, when I want to find out the magnitude of this, first I cap's coefficient square I have to take, right? A under root A1 whole square. So under root I have kept A1 square. Yes, Abdullah, what is the square of I cap? Yes, Abdullah, this is the example. Square of I cap. You're listening, Abdullah, or not? No response from you. At least say yes or no. Coefficient of I cap, I'm asking. Martin?
Yeah, ma'am.
Coefficient of I cap?
1.
1.
I cap, right? Yeah, 1.
1. Very good. It is 1. Don't get confused. It is 1 only. Yes, Abdullah, clear or not? It is 1. See, coefficient means just take the quantity and whatever is left, that becomes its coefficient. So here nothing is mentioned. It means 1. 1 into I cap. That's why it is written. So 1 square plus coefficient of J cap. Humam.
2. Minus 2.
Minus 2. Yes, correct. Minus 2 whole square. Minus 2 whole square plus. And for K, it's very obvious that this is 3. So 3 whole square. This way we have to solve it. So 1 square will become 1. -2 into -2 will become 4. 3 into 3, that becomes 9. So this becomes under root 14. So see what our answer has now become. A cap, the unit vector. A cap will be the vector as it is. What is the vector? I cap minus 2j cap plus 3k cap. This is the vector divided by its magnitude. I have obtained the unit vector of the vector. This is how we solve the questions. One more question we'll see, but before that, no classes, note down this part. Till here, you all have written. From here, note.
Ma'am, can you just recap what you taught?
Sarah, you have now you have just come.
No, a little.
Did you hear this magnitude part, Sarah?
Yeah, that I heard.
So see, magnitude, whenever we are calculating the unit vectors, what do? We take the vector as it is, the vector quantity. In the last class, we have studied that this is the representation of a vector. So this is how we take. Okay, Faisal, no issues. Vector as it is, I cap minus 2j cap plus 3k cap divided by its magnitude. And how do we take the magnitude? Under root, whatever is the coefficient of I cap, square of it, plus square of coefficient of j cap plus square of coefficient of k cap. Then we take the ratio. That way we have obtained the unit vectors. You will be getting separate question. Class 11th, you will be getting separate questions to make the unit vectors. Sometimes just tell the magnitude. I'll show you one question. When you just note it down, we'll discuss one question with you. All those who have written, meanwhile, you can send me your answers in the chat column. Very easy question. It's actually easier than the example which we discussed. Send me at least the magnitude part, all of you should send. This magnitude part. What is the magnitude coming? All of you in the chat column. Yes, very well. Sarah has answered. Others, what is the answer for the first part coming? Calculation is very easy for this part, first part, because the example itself is very easy. This you can even do orally without even writing it in your registers. Yes, answers from Abdullah, Faiza, Humam, Martin, Yasir, Siddiqa. Yasir, your answer also. No, see, some of you aren't able to solve this, I'll help you with it. Look, for the first part, we have to find out the magnitude. So firstly, do not forget to put this under root. Without this, your answer would be incorrect. So till now only Sarah has answered it correctly. Humam also correct. Coefficient of I cap is 1. So square of it becomes 1. No, Siddhika. Slight error that has led to the incorrect answer. Look here. Till here, your answer is right. But see, plus coefficient of j cap. Coefficient of j cap is -1. So square of it is this. Plus coefficient of k cap is -1. So square of it is this. Now look here. Under root. What is 1 square? It's 1 plus. What is -1 square? -1 into
The
-1
answer is
is
3.
1. Yes?
The answer is 3.
Root 3. It would be root 3. Yes. -1 into -1 is 3. So that becomes root 3. Fine. Now coming to the unit vectors, once you have obtained the vector, calculation of unit vector is not difficult. Unit vector is basically the vector divided by its magnitude. Vector is I cap minus j cap minus k cap divided by root 3. You can even in your exams, you can leave your answer like this also. You can separate all the denominators. Quickly note this down, those who haven't. Then we'll discuss a very important factor from this addition and subtraction of vectors, because this part will be used a lot in your calculations. Addition and subtraction more than this. For unit vector questions, no, this question, these are very specific questions for your class 11. But addition and subtraction, these are not just restricted to your class 11 portion. Anywhere you can need it, wherever directions are given. In class 12th also, you have lessons like magnetics. There also you will be needing addition and subtraction. See, addition and subtraction is actually very easy. It is very useful. This I'll tell you, you will be needing it everywhere. So this I'll mention that this is very useful. But actually addition and subtraction, these are very easy, very easy. You will be able to do it. It's just that, remember one technique to solve this. You have one vector, A1 I cap, A2 J cap, A3 K cap. You have another vector B vector, B1 I cap plus B2 J cap plus B3 K cap. Suppose let's say this is first force, second is second force. You have two vectors with you. How to add it? Like coefficients get added together, like coefficients get subtracted together. This is just the basic rule of it. This is just basic formula which you have to remember. A1 is the coefficient of I cap from first vector. B1 is the coefficient of B of I cap from the second vector. Add these two get added together, these two get added together, these two get added. A1 plus B1 with the unit vector I cap. A2 plus B2 with the unit vector J cap. A3 plus B3 with the unit vector K cap. You subtract these, you will get subtraction answer. You add these, you will get the answer of addition. For example, let me discuss. See, these are two forces given. What is the best method to solve them? Add these two vectors, add these two vectors, add these two vectors together. Fine. This is how your answer you will be able to obtain. Now look, E vector plus F vector, what will it be? 3 plus 2 with I cap plus. What is the next set of j cap we have obtained 2 plus 9 j cap. Next set. Coefficient of k cap is not given. It means this is 1 here. So that is -1, right? So -1, coefficient here is plus 3 k cap. Just understand this part well. -1 plus 3. So what is the answer to E plus F? 5 I cap plus 11 j cap. 5 I cap plus 11 j cap plus 2 k cap. Very good, Faiza. Plus 2 k cap. Correct. And E vector minus F vector. So you have to subtract these. That is, this becomes 3 minus 2 I cap, then 2 minus 9, because whatever vector you are considering, consider it in the same manner. It's not for my ease that I'll take 3 minus 2 here and 9 minus 2 over there. Right, that becomes incorrect. So this becomes plus 2 minus 9 j cap plus this becomes -1 minus this 3 k cap. So answer by Pfizer is 1 I cap, that is I cap. Yes, right. I cap minus 7 j cap minus 4 k cap. Very good. Perfect. So E minus F vector, this becomes 3 minus 1 is 2, that is 1 only. So I cap 2 minus 9 is -7. So -7 j cap -1 minus 3 becomes -4 j cap. This is how you add and subtract two vectors. Quickly noted, we'll see 1 or 2 questions from this part. After this, we have to start with parallelogram also. Note it down from here. One question I'll give you, all of you should respond. What has happened to Abdullah? Abdullah, aren't you present in the class?
Could you scroll?
Okay, go back up. Yeah, ma'am, can you go down?
Class, those who have written till here, answer me this question. 3 I cap plus 6 J cap minus 2K cap. B is 0 I cap. See, here 0 I cap is mentioned. Otherwise, in most of the questions, this is not written. So this could also be written like minus 4J cap plus 3K cap. Means 0 I cap. That's why nothing is written. But here I have mentioned it. You have to tell me the magnitude of resultant vector C. Resultant means addition of both of these. Pfizer, magnitude of resultant vector. Not just the resultant. Magnitude we have studied? Okay. Sarah, same thing. Okay. Whenever, please read the questions carefully. Magnitude of resultant. So Faiza's answer is 2 root 3. Sarah's answer is root 30. Any other answer by anyone? Humam, your answer? Magnitude of resultant. Martin, Yasir. Siddhika, you have also not answered any question. Yasir? Yes, Humam's answer is right. Humam has obtained the correct answer. See, when we are adding these two vectors, others, if you are on your way to find the answer, so complete it, and while I'm discussing, tell me in the chat column. See, when we are adding these vectors, it says that A vector plus B vector gives you C vector. This is what the question is saying. So A vector is 3I cap plus 6J cap minus 2K cap plus, what is your B vector? 0I cap minus 4J cap plus 3K cap. What have we studied? This gets added, these two get added, these two get added up. Root 38. No, I think root 38 is, let's see, let's check the answer. I think Humam's, your answer is right. Root 14 should be the answer. But let us check. I don't remember the answer exactly.
I got my mistake.
What you're getting, Sarah?
I think I did like there's plus 6 and minus 4, right? So I did plus 4 of them.
So send me your answer. do it again. Do
Yeah.
the calculations again. So C vector. Look here. 3 gets added with this 0. So we have 3 plus 0 I cap. Then 3 plus 0. Pfizer is
3.
also getting now root 14. This is plus 6. And here we have minus 4. So this J cap. Okay, you people have just added the magnitudes together. 6 plus 4 you did. Minus sign has
It's
been
6 minus 4, ma'am. I'm getting root 6.
how much are you getting, Martin?
6.
6. No, 6 shouldn't be the answer. Look here. 3 plus 0 I cap. 3 plus 0 I cap. 6. From here 6. From here minus 4. So 6 minus 4 J cap. Plus what about K cap? From here we have minus 2. From here we have plus 3 K cap. So what is the resultant? 3 plus 0 is 3. So 3 I cap. 6 minus 4 is 2. So 2 J cap. And 3 minus 2 plus 3 is plus 1. So plus K cap. Sarah is also now getting root 14. Okay, I think you people have neglected the minus sign. That's why the answers were getting huge, right? 6 plus 4 or maybe like this. Then magnitude is being asked. This is also not the answer. 3I cap plus 2J cap plus K cap. So 3 square plus coefficient here 2 square plus coefficient of K cap is 1 square. So this becomes 3 into 3 is 9 plus 4 plus 1. That becomes root 14. So root 14 is only the answer. That was answered firstly in one attempt correctly by Humam. Note this down. Note down the solutions, those who haven't done. Meanwhile, others answer this. This would be the last question from your unit vectors. This much is there in unit vectors, nothing else. Their multiplication and division, no, that comes under dot product and cross product. So that we'll do separately. That's why we are just doing addition and subtraction till now. But tell me the answers for this part. Question 2. First, note down the solution here, then attempt this. Again, same thing. This is the same question. You have to tell me the magnitude of the vector. So calculate the magnitude of this resultant R. Sarah has answered. Yasir has answered. Where is Abdullah today? No response from Abdullah yet. Faiza is calculating. Humam, you also answer this question. Martin, Siddika, where are you, Siddika?
I'm calculating, ma'am.
Yes, Siddika, calculate at least this question. You should also answer. This would be the last question from this. If you answer this well, it means you have understood. And today's class assessment, all of you will attempt. It would be based, I'm not including any other topic, parallelogram law or any other topic. It would be just based upon this only, I cap, J cap, K cap, these unit vectors only. So if you have really understood how to add them, subtract them, you will be able to solve the assessment. But before that, others answer this. Only Sarah and Yasir have attempted. Faiza is calculating. Faiza, you also quickly answer the magnitude. Okay, I think all of you have. Martin hasn't
Yeah,
answered.
ma'am. Yeah, no, sir.
Martin and Abdullah, I don't know what has happened. Internet is not working or he's.
No, I'm here, ma'am.
Fine. See, H vector is given 2I cap minus 2J
Root
cap.
60.
How much you're getting, Martin?
Root 62.
Root 62. Root 62 is the answer of Martin. Root 14, Humam. Faiza, root 12. Siddika, root 6. Yasir, root 61. Sarah, root 90. All the answers are different. No two answers are coinciding. And Martin's answer was root 62. Yasir, root 61. Root 6, Siddika, root 90. Let's see then the answer. I do not remember the answer. I also have to solve it right now. See, H vector minus I vector we have to do. H vector minus I. So it means you have to subtract these two, then these two, then these two, right? This is how we have to subtract them. So this becomes 2 minus, this is minus 3. I cap plus. We are having this as minus 2 minus this is 4. J cap plus minus 1 minus this is 0. K cap. Difference is that we used to add these. Now we are subtracting these. So resultant is 2 minus minus 3 becomes plus. 2 plus 3 is 5. 5 I cap. Then minus 2 minus 4. This becomes minus 6 J cap. -1 -0. This is -1 k cap or minus k cap. I would write it. Now, this is the vector. All of you, please cross-check your answer till here. Now, when we have to find out the magnitude of the vector r, resultant vector r, this becomes under root. We have to take square of I cap plus square of this. So this becomes square of -6 whole square plus k cap is -1. So this becomes -1 whole square. So we are left with 5 squared. This becomes 25. See, -6 into 6, that becomes 36. So plus 36 and -1 into 1, this becomes 1 with an under root. So 25 plus 36 is 61. 61 plus 1 is 62. Root 62. So Martin's answer was correct out of all the answers. Root 60. 25 plus 36 is 61, no? And plus this one. So root 61. Yes, yes, yes. So root 61. And then, right, this is root 61. And we'll add this one, that becomes 62. Do you all agree till here? Cleared or not?
Yes, ma'am.
Yes, ma'am.
So Martin's answer was right. All of you noted down. Where was the error? All of you, these different answers were obtained. No, Yasir, you had also written root 61. You had not added this one. You forgot this one. Okay. And what about you, Faiza, Sara, Siddika? Why your answers were different? Humam? Means exactly now you must know your mistake.
Yes, ma'am.
Negative sign outside the bracket. Okay, which went wrong. Just do not forget their sign. See, each coefficient sign will be there. Otherwise, your answer will be different. Like if this is -3, so include -3. But this would be negative. That would be fixed. So 2 minus, if had it been 3, we would have written 3. If it is -3, so 2 minus -3 it would become. Okay, note it down. Then we'll discuss parallelogram law. Now, coming to the parallelogram law. So in the last class, I had told you, now we are moving on to polar form. Cartesian form we did first, unit vectors and I cap, j cap, k cap. These are used to tell the direction. These are actually used to tell the direction. Fine, magnitude is given separately. That is a different thing. But I cap, j cap, k cap, these are mainly unit vectors are used to tell the direction. Now coming to polar form also will be used everywhere. Vectors are very basics. So addition of vectors requires three laws: parallelogram law, triangle law, polygon law. Now derivation of parallelogram law only comes. Triangle law and polygon law, the resultant answer is same. Whatever answer no, we'll obtain through parallelogram law. I'll do the derivation right now with you so that step by step you are able to remember. And in your class 11th, derivation questions can come on parallelogram law. Right? To prove parallelogram law, proper derivation you have to show. When you will jump into class 12, then no need to use the derivation, but the formula for magnitude and direction will still be used everywhere. Now, the first criteria, there are two criteria which you have to remember for parallelogram law of vector addition. Firstly, you can only consider two vectors at a time. When you have two vectors, when we will see the formula also, no, after derivation, you will notice A and B or P and Q, only two vectors, A and B vectors are used in the formula. So what about the third one? Suppose three cards are moving with three different velocities. How will you solve your answer? So in those cases, wherever you have such questions where more than a single vector is given, so you solve it one by one. For example, V1 and V2. What will I do? I will solve V1 vector, V2 vector first, and maybe I'll get the resultant over here. This will be the resultant. So I have solved this vector and I have obtained here. Now what will I do? Now I will solve this vector with this vector to obtain my resultant. So here also you will see two vectors will be obtained like this. This was, suppose you have A and B, or here we are talking about VR and V3. This is vector VR, this is vector V3. Then you solve them, and whatever is the final resultant, that will be your result. This is how three vectors or four vectors or five vectors, these are solved. But when you are considering during the calculation part, you will be considering only two vectors at a time. And this, when you will see the formula also, no, that time also you will understand that only two questions you are able to, only two vectors you are able to consider, because the formula only gives space for two vectors. How will you put in the third one? This way only, by taking the resultant, then the resultant with the next, then the resultant with the next. Then we discussed anti-parallel vectors, parallel vectors, equal vectors, negative vectors. One type of vectors that was left and yet to be discussed, this is coinitial vectors. So coinitial vectors means, remember I had told you, this is how we represent a vector. This is the head, this is the tail. I think you all have written it also. This, yes, head and tail, I have discussed this with you. This part is known as the head of the vector, and this is known as the tail of the vector. When we are talking about coinitial vectors, for coinitial vectors, both the vectors should have their tails coinciding. Tails should coincide for coinitial vectors. It means this is one vector A, this is one vector B, with whatever angle they are subtending in between. This is valid. Here you can apply the parallelogram law of vector addition. Suppose this is given to you, you cannot apply the law. You cannot. Or if they are given at a distance, suppose this is one vector and this is second vector. So vectors have the property that you can shift it. So if you shift it, then this will, on shifting, this will become like this. Then it can be applied. Then you can apply in this case. But this is not valid for parallelogram law. Fine. And one more thing, how do you write a parallelogram law? What is a parallelogram? Before coming to its law, you should know what is a basic parallelogram. So parallelogram has two equal sides. Both the opposite sides are equal. This side is equal to this side, and this side is equal to this side. Now regarding their angles, opposite angles are equal. These two angles are equal. This angle is equal to this angle. Now, if you take all the angles and put it together, if you cut all the angles and put it together, this is, I think, an activity also in your class 11, then you will obtain 360 degree. That is valid for all the quadrilaterals, closed quadrilaterals we have. So for vector, for parallelogram law, what should be the case? You should have both the vectors representing the diagonals of the parallelogram. Like this is A vector. This is vector A. This is vector B with an angle between them. So if you look, this is actually, you can complete the parallelogram here. So can you not conclude the fact that these are two the adjacent sides of a parallelogram? We'll come to the formula later on, but this is how your parallelogram looks like. It means you can apply, they are co-initial also. These are two vectors also. You can apply your parallelogram law. Two vectors, if they represent the adjacent sides of parallelogram, like this or like this, you can complete the parallelogram. If such is the case, then their resultant is always given by the diagonal of the parallelogram. This is how the resultant is given. The resultant is always given by the diagonal, and resultant will make an angle beta. This beta's detail we will see. This is how we consider the parallelogram, and this is the parallelogram law. The law basically says that if two vectors acting at a point, one represented in magnitude and direction by the sides of parallelogram drawn from the same origin, then their resultant can be represented by the diagonal of the same parallelogram. Means two vectors are there which are representing the sides of parallelogram from the same origin, means they are co-initial. Then the resultant is represented by the diagonal of parallelogram. These are for vectors and this is for the resultant. There are three steps we have to perform. First is the geometrical construction. Means if your two vectors are given, complete and form it in the form of parallelogram. Second, magnitude. You have to find out the magnitude of the resultant. And lastly is the direction. Because we are talking about vectors, so magnitude with the direction will be there. But before coming on to that, note down these basic points. Then I'll start with the derivation. From here, note it down. Till here you had written already in the last class. From here, note it down.
Now, what is that? The V cube? What is that V cube?
Which one? Here.
That J cube, yeah, down there.
This one.
Yeah.
V3. This V3. V3 and VR. Now, see the first step in derivation. So 3 steps we'll do. What was the first step that we discussed? First step that you have written is completion of the diagram. That is, if this is a vector given to you, this is the vector that is given to you. These are the 2 vectors. This is vector A, this is vector B given to you. This is their point of origin. So what you will do, geometrical construction means you have to complete in the parallelogram. This becomes their resultant. Fine, this is their resultant. So let me name this as something else. I'll name it. I'll name this because we need geometrical construction over here. Fine, this is one side. This is vector A. Let me write it in the middle. This is vector A. This is vector B. Let me name this triangle. Let's say this is P, or this side is O. Let it remain as O only. This is Q, this is S, this is T. Now, one more construction in your derivation. This is just for derivation purpose, just for your derivation part. See, this is some angle that is getting subtended over here, the exterior angle of the parallelogram. This side, let's say this is N, I have dropped a perpendicular over here. This is the perpendicular. So what conclusions can you make from here? If we look conclusions, that this side OT is actually your vector B, and OQ is your vector A, right? This is your vector B. Also this vector QS is also your vector B only. Look, both the sides are equal in the parallelogram. And similarly ST will also be the vector A. This is the first step. What is the angle between A and B? Theta. Theta is the angle between the vectors. So angle between the 2 vectors. This is A and B. Okay, next step. Next step is to find out the magnitude of this. We have done the geometrical construction. Second step is this. Now, look at this triangle. If you look at this bigger triangle, triangle OSN, let me write it first. In triangle OSN, let me draw it separately here. This is the triangle. This was the perpendicular SN. This was point O. Here we had this as the point which we had taken of the side of the parallelogram. This is it. So see, from here, what would be OS? OS would be, if you apply Pythagoras theorem, this is right angle triangle. So right angle triangle, this is your hypotenuse, this is your perpendicular, this is your base. So H square will be equal to P square plus B square. So this becomes ON square plus this is your NS whole square. Now coming to this, what was this point? Q we had taken. What is your ON made up of? ON is actually the sum of OQ and QN. See, this entire is ON. So ON will be equal to OQ plus QN. So OS is actually equal to OQ plus QN whole square plus NS whole square. This is it, what we have on applying. This is using Pythagoras theorem. Fine. Now, 2 triangles we are having. One is this triangle. Now, in this, what we do, here I had taken theta. Remember the exterior angle of the parallelogram. This angle, theta I had taken. This is the exterior angle. Now I want to put in the value of cos theta from here and sin theta from here. Let me redraw the triangle so that from here only you can relate. This is theta, this is Q, this is N, this is S. This was the vector B which we had taken. This is the base. Again, this is hypotenuse, this is perpendicular, this is base. Now look here, in this triangle QNS, if I consider cos theta will become what? Base divided by hypotenuse, that is Qn divided by Qs. What is Qs? Qs is actually the vector B. This was not the diagonal of the parallelogram. We had taken it as B.
So
So
we
this is,
cross multiply it.
huh?
We cross multiply it.
We will cross multiply it. Yes, we will cross multiply it. So Qn will become Qs, that is vector B multiplied by cos theta. This is one thing that we have obtained. Secondly, here only what you can obtain in triangle this QNS, you can obtain value of sine theta. So sine theta, this would be perpendicular divided by the hypotenuse. So that becomes NS divided by QS. So again, NS, we have to find out NS. QS is again this vector B. So this becomes B sine theta. From here in this, among this, look here, OQ plus QN plus NS. OQ was what? OQ is the vector A only. So do we have all the vectors formula in terms of this? OQ is vector A, QN is B cos theta, and this vector NS is B sine theta. Let us put all these. This value, all these three, let's say this is equation number 1. This is equation 2, this is equation 3, and your OQ is equal to A. This is equation 4. So put all these 2, 3, 4 in 1. Put 2, 3, 4 in 1. So if you put in there, see what you will obtain. Resultant vector which we are finding will be under root what it was, OQ square, OQ. So OQ is A plus QN. QN is B cos theta. So their square plus. Lastly, we have NS square, that is B sine theta's whole square. B sine theta's whole square. This is what we have obtained till now. Now look, this becomes A square plus B square plus B square cos square theta plus 2AB cos theta. I have just used the identity A plus B whole square. That is equal to A square plus B square plus 2AB. So same thing here, A square plus B square plus 2AB cos theta, because cos theta is present. B means B sine theta square, that becomes B square sine square theta. Now look here. Among this, what I have done now, further to solve this, I am looking B square is here also, B square is here also. Let me take B square common. If I take B square common from here, I'll be left with cos square theta. And from here, I'll be left with sine square theta, right? I'll obtain this under root A square plus B square cos square theta plus sine square theta plus 2AB cos theta. Now cos square theta plus sine square theta is actually equal to 1. So it means this term becomes 1. What is the resultant coming? Under root A square plus B square. This becomes 1. So I'm not writing it, plus 2AB cos theta. This is how you write the entire magnitude. This is the final answer for resultant. This is still not, your answer is still not completed because we haven't obtained the direction. So for the direction, we'll do that, we'll complete the derivation. The direction part will also be there. But regarding your magnitude, this is how you find out the resultant of two vectors which are given. If A and B are two vectors, A and B are two vectors which are subtending angle theta, this is how their resultant's magnitude will be given. Diagram also we have done. Last that is left is direction, which I'll do in the next class only, because otherwise you'll mix up things. Note down this part. Direction, I'll do it separately. So class, prepare this formula very well. You should learn this formula. Under root a square plus b square. In the next class, I'll ask each one of you. This formula is so basic and many students forget it.
I'm gonna go back up.
Text me done in the chat column, those who have completed.
Yeah, ma'am, done.
Done, ma'am.